Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera. So this is my 5th video on redox reaction where we will discuss about oxidation and reduction in terms of change in oxidation number. Before I do the examples on the redox reaction, I will explain to you the 8 rules that you need to know in order for you to understand the change in oxidation numbers. So let's start. Okay, now let's look on the definition of oxidation and reduction in terms of change in oxidation number. For oxidation reaction take place when the oxidation number of an element increase, whereas reduction reaction take place when oxidation number of an element decrease. So what is oxidation number? So in order for you to understand the change in the oxidation number, you have to know 8 rules that comply with this oxidation number. So let's look at the first rule for oxidation number. Okay, the first one, it says here the oxidation number for all elements is 0. Okay, what does it mean by element? We have already learned about matter, where matter have 2 big groups, which is element and compound. Okay, an element have 2 type of particles, which is atom and molecule. So what is the example of an element that exists as atom? For example, the first element stated here in the table, you have sodium atom. So sodium atom is an atom. Okay, so sodium atom, the oxidation number is 0. Okay, similar to carbon, carbon are also atom of an element, and also helium. So this is the atom of an element, means it consists only one element. Okay, oxygen and chlorine is actually molecule. So oxygen and chlorine is molecule, but both atom in the molecule consist of the same element. This make the molecule still inside the element group, and because of that, the oxidation number of that molecule or that element is also 0. So if you can see here, the oxygen oxidation number is 0 and chlorine oxidation number are also 0. Okay, this is because it is molecule, but it is in the element group, not compound. What is the difference between element and compound? So you have learned that compound can also be molecules or ion. It's just that compound must consist of 2 or more elements. So I will explain later about compound. Now let's look on the second rules, where it says here the oxidation number for a monoatomic ion is equal to the charge of the ion. So the second rule says that monoatomic ion, what does it mean by monoatomic? Mono means one, atomic ion means atom, ion. So the atom have changed to ion. So it is equal to the charge of ion. So let's say we have the first example, the copper 2 plus ion, the oxidation number is +2. Note that we write the ion for copper 2 plus as Cu2 positive. So this is the charge of the ion, the positive 2 charge or 2 positive. So if the charge of the ion is 2 positive, the oxidation number for that ion will be positive 2. So the oxidation number will be positive 2. It is actually according to the charge of the ion. So same as potassium here, as you can see that potassium K plus, okay, it have positive 1 or 1 positive charge. So the oxidation number will become positive 1. Bromide ion, so it have negative charge there. So you have negative 1 as its oxidation number. And then you have oxide ion, 2 negative. So the oxidation number is negative 2. And aluminium ion, 3 plus. So the oxidation number is plus 3. So if you have any monoatomic ion, so let's say we have magnesium. Magnesium is 2 positive. Okay, magnesium ion is 2 positive. Why? Okay, because magnesium release 2 electron to form magnesium 2 plus ion. So the oxidation number for this ion is according to the charge of the ion. So the oxidation number will be plus 2. Okay, so it is automatically written that the oxidation number for magnesium will be positive 2. Okay, it will follow the charge of the ion. Okay, now let's look at the third rule. The third rule says that the oxidation number of the element in its compound for group 1, 2 and 3 in the periodic table are positive 1, positive 2 and positive 3 respectively. For example, okay, if you have lithium chloride, so now you have lithium chloride. Okay, which one is group 1, 2 or 3? So lithium is the one that is in group 1. So this is metal in group 1. So if you know that the metal coming from group 1, so automatically the oxidation number of that element is positive 1. So what we can see here is that the oxidation number for lithium is positive 1. Okay, so it is according to the group of the element. So positive 1. So it's for lithium there. Okay, another example, you have aluminium chloride. Aluminium chloride. Okay, aluminium is Al. Okay, Cl3. Why? Because aluminium is in group 13. So when aluminium is in group 13, it's actually form a positive 3 ion. So the oxidation number for aluminium here is according to the group. Okay, it is in group 13, so the oxidation number for aluminium will be positive 30. So it's actually followed by the group that the element is in. Okay, so same as the other example, you have sodium oxide. Sodium is in group 1. So the oxidation number for sodium is positive 1. And then you have magnesium. Magnesium is group 2. So the oxidation number for magnesium is positive 2. And that is the third rule. How do you recognize the oxidation number for an element? Now, let's look at the fourth rule for this topic. Okay, the fourth rule says that the sum, what does it mean by sum? Okay, the total addition of the number, we call it as the sum of oxidation number of the element in a compound is 0. What does it mean by the sum of oxidation number? Okay, let's say we want to calculate the sum of oxidation number for sodium chloride. So we just learn about the first 3 rules just now. So now we are summing. Okay, kita nak cari hasil tambah. Okay, oxidation number for sodium chloride. So what does it mean by total oxidation number? So let me write down the total oxidation number. The total oxidation number of sodium chloride is equal to the oxidation number of sodium and the oxidation number of chlorine. So we have to add both oxidation number. So when we add both oxidation number, it means that the oxidation number of sodium, we have learned before that sodium is in group 1. So this ion is group 1. So the oxidation number for group 1 is +1. And then we have chloride ion. So chloride ion is Cl-. So it is a monoatomic ion that have -1 charge. The oxidation number for chloride ion is -1. So when we want to total up or sum the oxidation number of sodium and chlorine, so we have to put +1 for sodium plus -1 for chlorine, and we end up that +1 plus -1, so you'll get 0. This means that the sum of oxidation number of the element in a compound is 0. So the sum hasil tambah kepada oxidation number bagi setiap elemen dalam compound tersebut adalah kosong. Jadi itu maksud dia. Okay, let's look second example. Now, tadi itu summation. Now, we want to determine the oxidation number for sulfur in sulfur trioxide. So let me write down the formula first. So this sulfur trioxide, okay, is a molecule. So we say that the total oxidation number for sulfur trioxide is equal to 0 based on the rule just now. Okay, now when you have the total oxidation number equals to 0, we will take the S here as an X value. So we put down the S as X, unknown value. We don't know the oxidation number for sulfur. And then we want to add the total oxidation number for oxygen. So oxygen, we already know that oxygen is in group 16. So oxygen have the charge of O2 minus. Okay, so oxygen have 2 negative charge. So the oxidation number for oxygen is -2 equals to -2. So now we want to add this -2 inside the equation. So x plus 3 times -2. Why did I put 3 there? Because okay, in this formula you have 3 oxygen atoms. So you have to times the -2 with 3. Okay, so 3 times -2 is equal to 0. So where do you get the 0? Because we know that the sum of oxidation number in a compound is 0. So now we can calculate the S, okay, the oxidation number for the sulfur. Okay, so X is equal to 3 times negative 2, it's equal to negative 6. So equals to 0. So X is equal to, so you bring this value from right to the left. Okay, because this is positive negative, so the total will be negative. So X will become positive 6. So you have to write down the positive walaupun, okay, benda tu kita tahulah kalau kita tulis 6 maknanya positive, right? But for oxidation number, the plus sign is compulsory. Okay, this is a compulsory sign for this topic. So you have to write down the plus sign. Okay, so X means the oxidation number for sulfur is plus 6. Okay. That is the meaning for the fourth rule. Okay, now let's look at the rules number 5. It says that the sum of oxidation number of the element in a polyatomic ion is equal to the charge of the ion. So as you can see here, the sum of oxidation number for ammonium ion. So this is examples of polyatomic ion. So poly means more than one. Okay, tadi mono. Monoatomic means one element only. Okay, if you have polyatomic ion means that you have more than one element. So the example given here is ammonium ion. So if you want to calculate the total oxidation number for ammonium, it is equal to the oxidation number. Okay, I will refer oxidation number as ON so that I don't have to write down the full terms of oxidation number. ON means oxidation number. So ON of nitrogen, and we will add 4 oxidation number of hydrogen. Okay, why I put 4? Because if you can see in the formula here, you have 4 hydrogen. So 4 is meant to times with the oxidation number of hydrogen. Okay, so now we have the oxidation number for nitrogen equals to negative 3. Why negative 3? Because nitrogen is in group 15. So the charge of nitrogen itself is 3 negative. So negative 3 plus with 4 times positive 1. Okay, so hydrogen, the oxidation number is always positive 1. Okay, so the total charge of the polyatomic ion here is negative 3 plus 4. So you'll have positive 1. And as you can see, this oxidation number is actually equal to the charge of the ion. Can you see that? Okay, the charge of ammonia is NH4+. Okay, now let's look at the rules number 6. Okay, you see here that the oxidation number of hydrogen in a compound is normally positive 1, except in metal hydride, which is negative 1. So what does it mean by this statement is that if you want to know the oxidation number for hydrogen in any compound, let's say in this example, it is hydrogen chloride. So hydrogen chloride formula is HCl. So the oxidation number for this hydrogen is always positive 1. Another example, if you have water, so water is H2O. So again, the oxidation number for hydrogen in this compound is always positive 1. The only exceptional that you have for hydrogen is when the metal hydride form. Okay, what does it mean by metal hydride? Okay, the second example given here is that it react with sodium. So sodium Na, okay, is a reactive metal. So if the hydrogen react with a more electropositive metal such as sodium, potassium or lithium, instead of having positive 1 as the oxidation number, it will have an oxidation number of negative 1. So let's say we have this formula of sodium hydride. So the oxidation number for hydrogen here is equals to negative 1. Okay, other than that, it will always be positive 1. So you just have to remember that the oxidation number for hydrogen is always positive 1, okay, except when it reacts with metal that is very electropositive such as sodium, lithium and also potassium. Okay, Na, Li ataupun K. Selain daripada tu, dia akan form positive 1 ion. Okay, now let's look at the number 7 rule. Okay, it says that the oxidation number for oxygen in a compound is normally negative 2. So why negative 2? Because oxygen is actually in group 16. So it will receive 2 electrons. It will become negative 2 charge ion. So it is normally negative 2 except in peroxide, which it will change its oxidation number from negative 2 to negative 1. Okay, so if, let's say the first example, we want to search for the oxidation number of oxygen in magnesium oxide. So as you can see here, magnesium oxide have a formula of MgO. Okay, so note that the oxygen here will always be negative 2. Okay, so oxygen always negative 2 except when it react with hydrogen to form hydrogen oxide. Another example of oxygen, let's say you have calcium oxide. Okay, calcium oxide, so the oxidation number for oxygen here is also negative 2. Okay, always negative 2. Okay, now let's look at the second examples for this rule. Okay, if you want to determine the oxidation number of oxygen in hydrogen peroxide, so we are actually want to determine the oxidation number of oxygen. So I write down the formula first. So the formula is H2O2. So in this case, when the oxygen react with hydrogen to form the hydrogen peroxide, instead of having the oxidation number as negative 2, it will have an oxidation number of negative 1. Okay, so instead of negative 2, it will have an oxidation number of negative 1. So this is the only molecule that have oxygen with an oxidation number of negative 1. Okay, for all other compounds, the oxidation number is negative 2. Okay, let's look at the last rules in this oxidation number. Okay, the rules is when oxidation number of element is in group 17. Okay, the oxidation number of element in group 17 in a compound is normally negative 1. Okay, why group 17 element have oxidation number of negative 1? They usually accept 1 electron to achieve stable octet electron arrangement. So the atom will accept 1 electron. So it usually have negative 1 charge. Okay, so the oxidation number of fluorine is always -1. The oxidation number of chlorine, bromine and iodine is usually -1 except when they are bound to a more electronegative element such as oxygen. Okay, what does it mean by electronegative element? Means the atom have a stronger ability to accept electron, to attract electron and become negative ion. Okay, so oxygen have a stronger ability to accept or to attract electron towards the atom and to form a negative ion. Okay, thus the oxidation number will have a positive value. Okay, the first example that we can see here is hydrogen fluoride. So hydrogen fluoride have a formula of HF. So in this case, okay, in this rule, so this fluoride will have oxidation number of -1. Okay, so the oxidation number is referring to the charge of the ion. Okay, look at the second example here. Now we are going to calculate the oxidation number of chlorine in potassium chlorate. So this is the formula of potassium chlorate, ClO. So now we are looking at the formula of the compound. So we want to search for the oxidation number of chlorine. So using the previous rule, we say that the total oxidation number of element in a compound is equals to 0. So let's say we say that this is as an X value, unknown value. So we say that the oxidation number of potassium plus the oxidation number of X plus the oxidation number of oxygen will equals to 0. So this is how we calculate the oxidation number. So now we have the oxidation number of potassium. Potassium is element in group 1, so the oxidation number will be +1. So this is the oxidation number for potassium. So plus with X and then plus with oxidation number of oxygen. So oxygen, again, we have already discussed that oxidation number of oxygen is always -2. Okay, so this is total up to 0. So now we are looking at the X value. So when I add all these numbers, so this is plus minus, so it will be minus. So +1 plus X minus 2 is equals to 0. So +1 minus 2, so X minus 1 is equal to 0. So X will be equal to +1. So instead of having a charge of -1, the oxidation number for chlorine or chloride, okay, in potassium chlorate have become +1. So usually the oxidation number is -1, but in this case, okay, the chlorine have positively charged ion, or you can also say that the oxidation number for chlorine is +1. Okay, so now look at the last examples for oxidation number of bromine in bromate ion. So the formula is BrO3 negative. So we are searching for the bromine in bromate 5 ion. So this will become the X value, and then we add 3 because of the 3 oxide there. So 3 times oxidation number of oxygen is equals to the total charge of the polyatomic ion. So that will become -1. So now we have the X value. So X is plus 3 times -2. So the oxygen is always -2 equals to -1. So X plus 3 times -2. So you will have -6 there equals to -1. So this is plus minus, so it will become minus. So X equals to -1 plus 6. So X will be positive 5. So this is the oxidation number for bromate. So we write here the oxidation number for bromate is equal to plus 5. Okay, and if you look at the name of the compound, you will see that this Roman number is actually referring to the oxidation number of bromine inside the polyatomic ion. So this is actually how you determine an oxidation number of an element. Okay, after we have learned about this 8 rules, so how are we going to use this? Let's see an examples of a redox reaction. Okay, let's say now I have a reaction between magnesium and hydrochloric acid. So this reaction is between magnesium as an atom, okay, that react with hydrochloric acid, which is ion, okay, and then the product formed will be magnesium chloride, which is an ion, and also hydrogen gas. So hydrogen gas is a molecule. Okay, now during this reaction, we have to determine the oxidation number for each element. So the oxidation number for the first element, magnesium. So as you can see here, magnesium from atom. So the first rule, okay, magnesium is an atom of an element. So the oxidation number is equals to 0. It changed to magnesium ion, which have 2 positive charge. So the oxidation number have already changed from 0 to positive charge. So the definition of oxidation number in terms of change in oxidation number is that when the oxidation number increase, the reaction is oxidation reaction. So this reaction, okay, increase in oxidation numbers, okay, so the reaction is oxidation reaction. Okay, that is the reaction, the first reaction that we are looking in. Okay, sorry, so you have to balance the chemical equation first. So you have to hydrochloric acid, okay, to balance the chemical equation. Now we look at the hydrogen ion. So what happened to hydrogen ion? Okay, the hydrogen ion, okay, from an ion with +1 charge. So this is +1, or you can see 1 positive. Okay, the ion hydrogen always +1. It changed into molecules that is in element group. So it changed from +1 to 0. So as you can see here, the oxidation number decrease. So by definition, when the oxidation number decrease, the reaction is called reduction reaction. So same as all the definition that we have learned before, the substance that undergo oxidation is the reducing agent, and the substance that undergoes reduction will become the oxidizing agent. So what about chloride? Okay, if you look at chloride here, so chloride is an ion in hydrochloric acid. So the oxidation number is -1. Okay, chloride group 17. Okay, the charge is -1. So the oxidation we say that the charge is 1 negative. So the oxidation number is -1. So when it react with magnesium and form magnesium chloride, it still exists as ion with the same charge, 1 negative. So the oxidation number, okay, does not change during the reaction. So when the oxidation number is still the same, so chloride ion does not undergo oxidation or reduction. So the focus of element in this reaction is actually magnesium and also hydrogen. Okay, let me give you another example of redox reaction in terms of change in oxidation number. So let's say I have magnesium again, okay, react with copper sulfate. Okay, so this is a reaction where magnesium is a more reactive metal, so magnesium can replace copper ion from copper sulfate solution. So this reaction will produce magnesium sulfate and copper atom. So this is atom. Okay, copper sulfate exists as ion, and then the magnesium will release 2 electrons to form ion, and copper atom will form. Okay, copper ion will accept 2 electrons to form copper atom. So now when we are looking at this reaction, we can see that again magnesium change its oxidation number of an atom, magnesium atom, so the oxidation number is 0, it changed to +2. So again the oxidation number increase. So this reaction is oxidation reaction. Okay, and then you see that in this reaction, copper will change from copper 2 plus ion to copper atom. So this +2 oxidation number for copper 2 plus ion will change to copper atom. So copper atom have an oxidation number of 0. So you have decrease in oxidation number. So this reaction is reduction reaction. Okay, so same goes for the agent. So oxidation reaction, magnesium is the reducing agent. So copper 2 plus ion or copper sulfate is the oxidizing agent. So if we look at this equation, we will determine that sulfate remain as sulfate, okay, in the reactant, and the product part, sulfate is just being sulfate ion, so it does not undergo any change in oxidation number. So the focus of element in this reaction is magnesium and copper ion. Okay, we will look several examples later on, so don't worry too much because we have lots of application regarding the redox reaction that we will look into in the next video. Okay, that's all for this video, so I have explained to you the 8 rules that you need to know in order for you to determine the oxidation number of an element. Okay, so in the next video, I'll be explaining the IUPAC nomenclature. Okay, how do you name a transition element, especially using the Roman number. And then we will see some examples on the redox reaction in terms of transfer of electron and change in oxidation number. Okay, so see you in the next video. Thank you.